Hi dear students. Now we will have a discussion on the factors which affect the distribution of temperature. They are latitude, altitude, distance from the sea, winds, ocean currents, clouds and rainfall, slope of the land, vegetation and nature of the soil. Let's see how latitude influence insolation, or what is the connection between latitude and rate of insolation. Temperature depends on the latitude of a place because it determines the angle of incidence of the sun's rays. Temperature decreases with increase in latitude on either side of the equator. The zone between Tropico Cancer and Tropico Capricorn gets the maximum insolation because the sun's rays are closest to the vertical. Temperature decreases from the equator to the poles because the sun's rays become increasingly slanting. For example, within India, places in the southern part of the country which are closer to the equator are warmer than the places in the northern region. Thus, there is a close connection between latitude and rate of insolation. The places situated near the equator receive high amount of insolation than the places situated near the poles. Because near the equator, sun rays are direct and near the poles, sun rays are slanting. Next factor which affects the distribution of temperature is altitude. Height of a place above the mean sea level is known as altitude. The higher the altitude, the lesser is the temperature because air is cooler at higher altitudes than on the Earth's surface. Heat absorption capacity is more in the lower layers than in the upper layers where its density is less. For example, air resting over the mountain peaks is cold even though it is closer to the sun. Students, here you have to know normal lapse rate and temperature inversion. With the increase of height, temperature decreases. For every 166 meters, the temperature falls by 1 degree Celsius. For every 166 meters, the temperature falls by 1 degree Celsius. This is known as normal lapse rate. However, some places where certain special conditions in the lower atmosphere produce a reversal of normal lapse rate so that temperature actually increases with an increase in altitude. This is known as temperature inversion, just opposite of normal lapse rate. Under some special conditions, temperature increases with an increase in altitude. This is known as temperature inversion or inversion of temperature. Let's see how distance from the sea is a factor which affects the distribution of temperature. Land surface gets heated rapidly and cools rapidly. Places close to the sea experience moderate temperatures known as maritime influence. Places situated in the interiors or away from the influence of ocean experience high temperatures during the day and very low at night, known as continental influence. For example, Daily and annual range of temperature at Kolkata is lower than at many places in the interior of India, even though they might be situated at the same latitude. Winds also modify the temperature of a place where they blow. Winds which blow from sea to land are called the onshore winds and carry moisture. The winds which blow from land to sea are called the offshore winds. Winds of different character influence the climate of the areas in a different way. For example, the hot winds blowing from Thar Desert during summer raise the temperature in the western and central parts of the Gangetic Plain in India. The cold wave in the northern parts of India during winter is a result of cold winds blowing from higher latitudes. Let's see how ocean currents influence the distribution of temperature. Ocean currents increase or decrease the temperature of Earth's surface. Currents influence the temperature of the coastal regions along which they flow. With the help of few examples, we can understand this. Ports along the eastern coast of Canada remain frozen in winter due to the influence of cold Labrador current. Likewise, the western coast of Norway remain free from ice due to the influence of warm Norwegian current. Thus, cold ocean current can decrease the temperature. Warm ocean currents will increase the temperature of a place. Next, we can see how clouds and rainfall affect the distribution of temperature. Clouds are formed from water that has evaporated from oceans, rivers, and lakes. This evaporated water cools and condenses, forming clouds. It comes down in the form of precipitation and moderates the temperature of the place. Dense cloud cover prevents incoming solar radiation as well as checks outgoing terrestrial radiation. The regions where there is no cloud cover, example hot desert, there is a high insolation during daytime and rapid loss of heat due to terrestrial radiation at night. So, deserts are hot during the day and cold by night. Slope of the land also affect the distribution of temperature. Areas of steep slopes show thermal contrast due to the aspect of the slope of the land. For example, in the Himalayas, the south-facing sunny slopes are warmer than the north-facing shady slopes. Slopes facing south in the northern hemispheres are warmer than those facing north because the sunrise strikes the south-facing slopes at a steeper angle than they do at the north-facing slopes. Vegetation and nature of soil are the modifiers of temperature. For example, temperature in dense forest areas is lower than in the neighboring open areas in the same latitudes. Dry, sandy soils get heated and cooled rapidly, while the wet, clayey soil warms up and cools down slowly. Students, I hope now you are familiar with what is insolation, what are the three ways by which the atmosphere of the earth is heated, and the factors affecting the distribution of temperature. It's a time to wind up our session. Thank you for your cooperation. Thank you.